So let's go ahead in this video and we'll design and we'll simulate an exclusive NOR function. Now we've seen whenever we did the half adder that we used the exclusive NOR in the sum section. So this was the half adder for the CMOS and this is the sum section here. And this was the carry section. So we've seen this in a previous video. Now the schematic for it is this here. So we've got the two bits coming in, A and B, and we've got an exclusive NOR here for the sum, and we've got a NAND there for the carry. And in order to get the actual sum and actual carry, we then put them through an inverter. So this will give us the actual sum and the carry as opposed to the not sum and not carry. So this is the inversion of that side. And here's the truth table for it here. So we said that if we've got 0 plus 0 is going to give us a value of 0 and the carry would be 0. 0 plus 1 would give a value of 1 and the carry would be 0. 1 plus 0 is a value of 1 and the carry is 0. And 1 plus 1, it would be 0 and the carry would be a value of 1. But of course, because we are working with our logic here, our pull down logic, we're going to actually generate the inversion here. So the inversion is the n sum and the n carry lines. So this is what we're actually going to generate first of all. So we want to build this little circuit here. So this is this section here. So this is the exclusive NOR. So I'm going to take a copy of that and we'll compare it to the layout, and we'll just work our way through and we'll build this up. Now a thing to note as well is that it doesn't matter what order the series values are in. So for example, I could swap the A dash with the B here. So I could swap these two round about. I could swap these two. I could swap these two. And I could swap these two. So in the series combinations, you can just swap them round about. It's not going to change the function. But of course, you can't change, if you were to swap them the parallel combinations round, then it's going to change the actual function. So let's go ahead and we'll go and we'll build this in the electric EDA tool. So just before we go, note that this is the truth table here that we're building. This is the exclusive NOR. So we get a 1 output whenever both inputs are low, and we get a 1 output whenever both inputs are high. But if any one of the inputs is low, A or B, then we get a 0 output. So this is the little bit of the truth table here that we're interested in, and this is the exclusive NOR function that provides this not sum. So I've gone ahead and I've built up the exclusive NOR function, and this is just the same as the function that we've seen in just a second ago. I'll go and bring it up just now. So this here. So this is our exclusive NOR function, and this is it just built up, and you can see that we're going to have the 4 PMOS gates, so that's the 4 gates here, and we're going to have the 4 NMOS gates, that's these 4 here, and we're going to have to get access to the inversion of A and the inversion of B, and we do that via an inverter. So I've just built the little inverter here. So there's an inverter for A, inverter for B. So this is going to be the A, and this is going to be the A dash, and this is going to be the B, and this one here is going to be the B dash. And you can see that I've just made the connections here the same as the connections are here. So I'll just read through one of them. Say for example, A dash, well that A dash comes to here. So A dash goes to the first one at the top, so it goes up to into this one, and it also goes to the third one down. So it goes in there and it goes to the third one down. So there and there. And you can follow through the A, the B and the B dash, and you'll see it's just connected the same as we have here. So you can go ahead and build that yourself, and you can test it out and see that it does actually work. Now let's move on and we'll show you the actual layout for it, and we'll talk through the layout because the layout is the interesting part for it. So double click on this and I'll zoom out a little bit so you can see. Again, the layout that I've produced here is maybe not necessarily the same as the layout that you would produce, and it's maybe not the necessarily the best or the neatest layout, but it does work, and it gives us what we're looking for. So let's talk our way through the layout and see how this layout matches up with the schematic. So we've got the inverter here that takes the A input and gives us our A dash. So we've seen the inverter before, we don't need to talk through it. We've got the PMOS at the top and the CMOS at the bottom. And we've also got the inverter here for the B. So the B comes in and you get the B dash coming out here. So that's the two inverters that gives us our A dash, B dash. We've got our VDD, our power supply rail up the top, and we've got our ground along the bottom here. But what's interesting is this little section in the middle. So let's have a look at the schematic and we'll make a comparison and we'll see exactly where all this comes from. So I'll just pop it there. So we're going to start off with at this point here. So this point here is our VDD. So that's the VDD here. So we can come from here and we get to this point. So this point is going to be this point here. We then go through the active region of this transistor. So that's us going through the active region of that transistor there. And we've got the gate, which is this gate here. So that's the gate for A dash, and you can see I've made a note there, A dash. Now the other side of this device here is connected to this side of this second device. Okay, so they're joined together, and we don't need to have a via here because we don't need access to that point. So there's no via in here. It's just the active region. And then we go through this device here to this point here. So that's us going through that device there. And that's our B dash gate. So that's our B dash. So we're coming down this way here. And that's us coming down along here. We get to the other side here. And we've got access to the active region via this via here. And we come out in metal 1. And we come across in the metal 1, that's the blue, over to this device here. So we're coming down, and this is the connection along here. And then we're coming up into the next device here. So this point here is this point here for this device. And then we're coming up through, and again, these two devices are joined together, and we don't have a via here, so we just have the join here. So that's just the active region, which is this area here. And then we have the active region for this transistor, which is the active region under the gate here. And this is the B section. And finally, we come out of here and we head up to the VDD again. So this little loop round and along and through here is this loop here. Okay. So you should be able to go and build that yourself with all the knowledge that you have so far with the previous devices. So all we've got really are two devices here in series and another two devices in series, and then we've put both of the lots of devices in parallel. And the output is coming from this point here. So this point is the center point here, that's the output. And this point and this point again is the same as this point and this point here. So we can follow this route down and out to ground, and we can follow this route down and out to ground. So when we come down through this path here, we're going through the A dash, so that's the A dash there, and through the B, and that's the B there, and finally this pin here heads off to ground. And the same from this side here, we're heading down through this point here, which is this point, and we're going through the A, that's the A there, and we're going through the B, that's the B1 there, so we head down through to ground. So again, these two here are in series, these two are in series, and both of them together are in parallel. And I've just joined up all of the relevant points, gates. So for example, this is the A dash, and there's an A dash here, so we can just join the polysilicon together, and that heads to the output here for this device, or well, the input for this device. And again, we do the same for the A. There's the two A's joined together, and it heads out and along this polysilicon to this point here. Just follow that round. That's an A, heads along, yeah, and that's the input there. that goes to the A of the input. And again, we can do the same for the B's. So the B joins comes up into this point here, and it gets in through, it goes up through onto metal 2, which is the big pink colour, and that's the B section. And again, the B comes along here and goes into this one here. And you can do the same for the for all of them. For the A dash, the A dash, he's A dash and A dash, the B and the B here, and the B dash, and the A and the A. So you can take your time and work your way through and follow your way through the layout. And I suggest you go ahead and try the layout yourself. And if you get any difficulties, you can always get in contact. And that's all there really is for the layout. What we want to do is go and simulate this device and see whether it is actually working. So if you head into there's another one here called the XNOR sim. So I've simulated the layout here. Again, double click on this and we've got the simulation set up as well. And again, you've got access to this file here in the resources section if you want to use it. It's the same as the previous videos. And we can go in and then go in through the tools and the spice and write spice deck, and you can see it's written out all of the parasitics here. And we'll go into tools, we'll go in here and grab the actual window. So we're going to be VA, VB and the Vout. We can OK that and add plot pane, and we'll take the VA up to the top, we'll take the VB here, and we've got our Vout here. And you can see this is the truth table that we were wanting to get. We get a high input in A and B, gives us a high output here and the output, and a low input in A and B gives us a high output. But if any one of the values of A and B are low, then we're going to get a low output. So this is giving us our exclusive NOR function. So finally, let's go and we'll have a look at this in the 3D window. So I'll head back into the actual exclusive NOR here, into the layout, and we can get into Window, 3D View. So we can see our 3D view here, and we have our inverters in the left and right. So this is giving us our A and our A dash, and this gives us the blue line here, the red line here is giving us our B input, and we're getting our B dash at this point here, and it feeds into our CMOS transistors at the top and our NMOS transistors here at the bottom. So that's our exclusive NOR function. Now there are other ways of implementing exclusive NORs that don't use as many gates as this. That's us finished with the exclusive NOR gate. In the next video we will go on and look at the final basic gate, which will be our exclusive OR gate. So thank you for listening. I'll get you on the next video. Goodbye.